Hi students, this is Chandrasekhar, Faculty of Physics. I have 15 years experience in teaching, particularly in different levels. So, in this semester, especially semester number 3, I did the paper is Solid State Physics. This Solid State Physics is the specialization paper in MSc Physics. Particularly in Andhra University region, you have mentioned two specialization paper as you wish. One is Solid State Physics, another one is Electronics part. Because out of 4 semesters, in 2 or 3 semesters, Electronics and Solid State Physics papers are there. So your specialization may be mentioned either Solid State Physics, otherwise Electronics, as you wish. But according to the data, our specialization paper is Solid State Physics. This semester I am dealing the paper, nothing but specialization paper. Very important paper. So solid state physics. Anyhow, I hope each and everyone is safe at your home. Be careful with respect to your health. If you are in healthy state, you have the bright future in future years. In COVID-19 time, each and everyone must follow the SMS. Each and everyone knows SMS is nothing but S, sanitizer, M, mask, and one more S is called as social distance. Up to COVID-19 during period, you must follow the SMS back. Anyhow, before going to our paper is Solid State Physics. Particularly, this paper code is PG 1932514. This is the paper code of your Solid State Physics in semester number 3. In Solid State Physics, different topics are there. Particularly in unit wise, 3 units are there. Unit number 1, unit number 3 and unit number 4. In unit number, there are number of topics are there. Especially in our topic name point of view, there are mainly 4 topics are there. One is crystal structure. Second one is crystal diffraction and reciprocal lattice. And third one, phonons and lattice vibrations. And fourth one, free electron Fermi gas. These 4 main topics are belongs to your unit number 1. Very important. Based on these 4 topics, you can explain any topic in solid state physics. So, particularly unit 1 is very important. After completion of unit 1, you have the unit number 3. That unit number 3 is the band theory of solids. And the last unit, that is unit number 4 in this semester, that is superconductivity. So these are the mainly 3 units are there in solid state physics. According to the data, before going to the complete paper explanation, first we can learn about what are the topics, particularly which topics are explained in this semester. So in this semester, unit 1, there are 4 topics are there. In every topic, some crystal, lattice and electron gas. In unit number 1, main words are repeated. One is crystal, second one is lattice, third one is electron gas. So, electron gas. So, according to the chapter number 1, you first learn about what is crystal, what is lattice, what is Fermi gas. Depending on these 3 words you learn about, each and every topic can be explained very easily. So, crystal, what is crystal? After completion of this unit number 1, you go through the third unit, that is band theory of solids. So, this can be explained about the solids. So, the solids can be explained on the basis of band theory. So, in degree, especially paper number 4, semiconductors are there. In semiconductor chapter, you learn about band theory. So, on that way, you can go go deeply or depthly, particularly band theory of solids. So, unit number 4 is superconductivity, particularly complete different topic according to unit 1 and unit 3. This is unit number 4, superconductivity. This superconductivity is mainly based on temperature. particularly based on temperature. So based on temperature you can explain the conductivity, particularly the temperature you can mention at low temperatures. You can explain the conductivity at low temperatures, then that phenomenon can be called as superconductivity. So you can explain the conductivity state of the material particularly at low temperatures, nothing but below the room temperature. Below the room temperature you can explain the conductivity, then the chapter goes to superconductivity, which is very important, because after completion of your MSc, you can go through MPhil or PhD level. In PhD or MPhil level, you can take one of the main topic is superconductivity, because present generation it is the very highly important topic, that is superconductivity, because each and every gadgets are manufacturing with semiconductor. So those semiconductor you can use the phenomena at low temperature, that is called as superconductivity. So superconductivity is also used in future years, nothing but you can go through the further studies. So superconductivity is also important. So before going to the topic, so our chapter or particularly paper name is solid state physics. This solid state physics simply called as SSP, solid state physics. In AU region, Andhra University region, this paper can be called as SSP. In ANU, Acharya Nagarjuna University point of view, same paper can be called as CMP. What is the variation in between SSP and CMP? SSP is nothing but solid state physics. CMP is nothing but condensed matter physics. Both are different. SSP is nothing but solid state physics and CMP is nothing but condensed matter physics. What is the difference between SSP and CSP? Particularly condensed matter physics, you can take the material. You can take the material. This material is compressed. Like as you can take vapor, otherwise gaseous state. If this vapor or gaseous, otherwise liquid, these states can be compressed. Then compressed vapor, gases or liquid is completely converted into solid. So the compressed liquid can be explained by using the physics, and the physics can be called as condensed matter physics. So particularly condensed matter physics, you can compress the material. But in solid state physics, you have the solid. So you can explain the complete solid properties, behavior, structure, etc. You can take one solid like this. The solid properties, behavior, structure, etc. can be explained by using the physics is called as solid state physics. So solid state physics is a branch of one of the part of condensed matter physics, because you can take here solid, you can compress it. You can compress the solid, new material is formed. That new material can be explained by using the condensed matter physics. So condensed matter physics is nothing but you can explain the behavior of the matter based on temperature. Nothing but compressed the material. That compressed material can be explained on the basis of condensed matter physics. So in Nagarjuna University point of view, their specialization paper can be taken as condensed matter physics. In the Andhra University point of view, our specialization paper is solid state physics. So based on solid state physics, different units can be explained in this semester. Particularly in semester number 3, there are mainly 3 units are there. Unit 1, Unit 3 and Unit 4. In out of 3 units, very large and biggest unit is called as Unit number 1, which is the important unit as compared to different units. This unit is learned clearly. You can easily go through the band theory of solids and superconductivity. So mainly you can clearly explain about the unit number 1. Solid state physics. In this chapter, you can explain first unit is crystal structure. In first unit crystal structure, you can explain the complete behavior of solid. Each and everyone knows in degree level and interlevel also known. Solid, actually it is the branch of or it is the part of matter. What is matter? Matter is nothing but combination of atoms. Combination of atoms, simply otherwise molecules also. So combination of atoms or molecules. So matter is nothing but combination of atoms. So depending on atom you can explain the matter. So by depending on this atom, what is atom? Simply atom is nothing but combination of nucleus and electron. Clearly, nucleus is nothing but it is the combination of proton and neutron plus electron. So atom consisting of very smallest particles number is 3. One is proton, another one is neutron, and last one is electron. Everyone knows the proton having the positive charge, neutron having the chargeless particle, electron having the negative charge. So positive plus negative is nothing but 0. So electrically atom is a neutral state. So atom is electrically neutral. Electrically neutral. Everyone knows the charge of electron is minus 1.6 into 10 power minus 19 coulomb. The charge of proton is plus 1.6 into 10 power minus 19 coulomb. And mass of electron is 9.1 into 10 power minus 31 kg. And mass of proton is 1.67 into 10 power minus 27 kg. These are the standard values. So each and everyone knows in lower levels, degree and intermediate level. So simply atom is nothing but combination of nucleus and electron. Depending on this atom structure, based on combination of atoms, matter can be explained. According to combination of atoms, matter can be divided into mainly 3 parts. One is solid, second one is liquid, third one is gas. So classification of matter based on arrangement of atoms, based on arrangement of atoms, particularly based on arrangement of atoms, matter is divided into 3 parts: solids, liquids and gases. According to our chapter is solid state phase. In this chapter, particularly in this paper, you can explain complete behavior of solid. So you can explain only solid. So based on arrangement of atoms, in solid the atoms are arranged side by side like this. Otherwise closely packing of atoms, otherwise tightly bonding of atoms. Then the structural arrangement can be called as solid. In liquid state, the atoms are arranged. They maintain some distance like this. Loosely packing of atoms. In gaseous state, the atoms are existed in free state. The free state atoms are existed, then the matter can be called as gaseous state. According to solid, the atoms are arranged side by side. According to the atom, you can consider one atom. This atom, which is in spherical in structure, the structure atom is spherical in structure. So this is spherical in structure. You can take this is center. From center to surface of the body, you can take as radius r. So every atom consisting of one radius. Here atoms are arranged side by side. Suppose you can consider 2 atoms. Those atoms are arranged side by side. Like think like this. So according to physical appearance, the distance between two atoms is zero according to physical appearance. But in microscopic level, these two atoms are separated with interatomic distance. Interatomic distance, which is indicated by letter small d. What is interatomic distance? The interatomic distance is nothing but here the two atoms are arranged side by side. In physical appearance, the distance between two atoms is zero. But according to microscopic level, the interatomic distance is nothing but the distance between center of the first atom to the center of the second atom. This is interatomic distance. Nothing but from center to surface of the atom is radius r. From center to surface of the body radius r. According to interatomic distance can be taken as d is equal to r plus r. Nothing but 2r. So in solids, the atoms or neighboring atoms are separated with interatomic distance. Then that structural arrangement can be called as solids. According to the based on structure, you can explain this property is. So that property must stand between atoms are arranged side by side. It is very hardest material. So solid strength is very high to break the solids. So according to the solids, the interatomic, so nothing but the neighboring atoms are separated with a distance of interatomic distance. That interatomic distance value can be taken as d is equal to 2r. This is solids. So according to the solids, they have the neighboring atoms are separated with interatomic distance. Based on interatomic distance, classification. Classification of solids. Based on interatomic microscopic level point of view. Interatomic microscopic level point of view, solids are divided into mainly two types. Solids are mainly divided into two types. One is crystalline solids. Second one is non-crystalline, otherwise amorphous solids. Crystalline solids and amorphous solids based on their interatomic microscopic level configuration. Atoms can be arranged in two different point of view. Based on that interatomic distance, solids is divided into two types. One is crystalline, another one is amorphous. According to the basic meaning of crystalline and amorphous, crystalline, the basic meaning is particular arrangement. The meaning of crystalline is nothing but particular arrangement. Amorphous is a Greek word actually. It is a Greek word. Based on Greek sense, amorphous in Indian language, the meaning of Indian language amorphous is random. Random arrangement. What are the arrangement? Here particular arrangement, here random. What is the arrangement? These are the particularly solids, crystalline solids and amorphous solids. Already you know that solids is nothing but combination of atoms. So this arrangement is nothing but atoms arrangement. So particular arrangement of atoms in the structure, then the structure goes to crystalline solid. Random arrangement of atoms in the structure is called as non-crystalline solid. So in crystalline solid you can take number of atoms like this. first atom, second atom, third, 4, 5, 6, 7, 8, 9. So I am taking the crystalline solid have 9 atoms. In particularly this structure is must and should be crystalline. We can explain on what way. The center to center neighboring atoms distance can be taken as d. So every neighboring atom of first atom must be separated with a distance d. In a similar fashion, second to third, 4, 5, 6, 7, anything, the neighboring distance must be constant like this, d, 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 d. So the distance between every neighboring atom must be constant. So they have a fixed atom position. They have a fixed atom position. So that particular atom position, that position of the atom is represented in crystalline solids, that is called as lattice. They have a particular lattice configuration. They have a particular lattice configuration. In amorphous is nothing but random arrangement. So there is no particular arrangement of atoms like this. So the atoms, first and second atoms are separated with distance d. Here neighboring atom is this. This may be greater than d. So distance is not same. Then the structural arrangement goes to non-crystalline or amorphous solids. Particularly in crystalline solids, they have the directional properties. Directional properties. So particularly solids can be explained in three-dimensional point of view. In every dimension, the properties are same. Then the material called as anisotropic properties. So anisotropic properties obeys the crystalline solids. Particularly non-crystalline solid, distance is different. So these are called as isotropic materials. Isotropic materials. So they have no directional property. So direction by direction their properties are changes. No directional properties. So direction by direction their properties are changes, then the material goes to isotropic properties. In direction by direction same properties are exhibit, then the materials are called as anisotropic in nature. Particularly in crystalline solids, they have a sharp melting point. Sharp melting point. Sharp melting point is based on structural arrangement. In every structure, atom to atom there existing certain bond. Particularly here bond is covalent bond. So out of the all bonds, covalent bond is very strong bond. You can give the temperature at a particular temperature. All bonds are broken at a time. So they have a sharp melting point. In anisotropic, particularly isotropic materials, the bonds is here small bond, here large bond. So you can give the temperature. First small bond is broken, after that next bond, after that, and nothing but ante manaki step by step bonds can be broken. So they have a weak melting point. They have a sharp melting point. They have a weak melting point. Particularly here all bonds are very strong. So in crystalline solid strength of the crystalline solid is very high. Nothing but which is in stable in state. Particularly in non-crystalline or amorphous solid, the strength of the solid is very low. Nothing but unstable position. So random. Nothing but amorphous solids are unstable in nature. Crystalline solids are stable in nature. In crystalline solid, they have two types of solids are there. One is single crystal, second one is polycrystals are formed. In crystalline solid, single crystal are formed, otherwise polycrystal. What is single crystal? Entire the solid or crystal, they have only one atom. that entire solid have only one atom, then the crystal is called as single crystal. More than one atom is existed in the crystal, then the crystal is called as polycrystal. Next, particularly in crystalline solid, best examples can be taken as sodium chloride, cesium chloride, diamond. These are the best example for crystalline solids. In non-crystalline solid, best examples can be taken as glass, plastic, rubber, etc. ఇవన్నీ చూడంగా మీకు ఒకటి గుర్తు రావాలి. These are the example for particularly glass, plastic, rubber. Example for insulators. Particularly example for insulators. So all insulating materials can be called as non-crystalline solids. All NaCl, nothing but electrolyte. Cesium chloride is electrolyte. Diamond is the best insulator. Particularly carbon, they have the structure is layer structure. That layer structure obeys also the crystalline solid. This is the major classification of solids. Based on classification, solids are divided into two types. One is crystalline, another one is non-crystalline. In crystalline solids, the particular arrangement of atoms are existed, then the solid is called as crystalline. Random arrangement of atoms are existed, that is called as amorphous. In crystalline solids, they have the particular position of atom can be represented as lattice. Lattice is the point or position of the atom. So in crystalline solids, directional properties are obeyed. The directional properties are obeyed element particularly is called as an isotropic nature. So all crystalline solids are obeyed and isotropic in nature. In non-crystalline solids, direction by direction their properties are changed. So those materials are called as isotropic pressure. In crystalline solids, you can give the temperature, each and every bond is broken at a single temperature. So they have a sharp melting point. Here bond by bond is broken, nothing but you can increase the temperature simultaneously. First bond is broken one temperature, next bond is broken another temperature. So they have the weak melting point. Strength of the crystalline solids is very high. So stability is also high. In non-crystalline or amorphous, strength is low. Those are in unstable condition. In crystalline solid, two types of crystals are there. One is single crystal, another one is polycrystal. In single crystal, the entire crystal having only one atom, single atom is existed, then the crystal is called as single crystal. More than one atom crystal are existed, then the crystal is called as polycrystal. Best examples are sodium chloride, cesium chloride, diamond, etc. Best example for amorphous is called as glass, plastic and rubber. This is the basic introduction part of our main paper, solid state physics. So solid state physics mainly based on this structural arrangement, crystalline and non-crystalline. In crystalline, you know the one new word is came, that new word is called as lattice. According to our data, what is lattice? Lattice is the point. At that point, the position is occupied by the atom. So occupied position, the constant, nothing but total mass of the body is concentrated at a particular point on the paper. That particular point can be called as lattice. According to crystal, the crystal position of the point can be called as lattice.